PowerPoint. So we're talking about special senses and general senses. So sensory receptors, specialized cells or cell processes that monitor external and internal conditions like pain and touch and temperature and so on. So a receptive field, I'll define that in a moment. And so we have all these general senses: temperature, pain, touch, pressure, vibration, and proprioception. Proprioception is the sensation of the position and state of contraction of your muscles so that we can walk and talk and do all the things we have to do to move. Muscle position and state of contraction is monitored all the time. Special senses: smell, taste, vision, balance, and hearing. So like the eye and the ear. Receptor fields, so for touch or pain, the different nerves are going to have an area where they are sensitive to a particular touch. And this is how we know where in our body we're being touched or where we're hot, because all these nerves have an area where they sense heat, pressure, touch, and so on. We all know that receptors can adapt. That means that after a while, when we sit down in a chair, we feel it. Then all of a sudden, we don't even pay attention to it. That's adaptation of a sensory nerve. Okay? So stimulation of a receptor produces action potentials that move along the axon, and the frequency and pattern of the action potential will tell the central nervous system what's going on. So a person's perception depends on where the information is being carried. So when you suppose you touch something warm, the information about where it is, the body will know, because location is everything, because we're wired so that in the spinal cord, on your arm and so on, or your upper arm or your face, those information from the sensory system are going to go to the place in the body. So if it comes from the face, the information goes to the cervical spinal cord. And so where things end up encode the information as to where they originated in the body. So pain are called nociceptors. So referred pain, we'll leave that one alone. Fast prickling pain, or slow burning pain. So we can distinguish between various types of pain, and that's because we have different receptors. So I'm not going to emphasize referred pain. Let's skip that. Thermoreceptors detect temperature. They have free nerve ending. They fast adapt. So cold receptors greatly outnumber the warm receptors. So they're found in the dermis, skeletal muscle, liver, and the hypothalamus. They adapt very quickly, meaning that once we notice the change, the heat, or the drop in temperature, we will stop noticing it. And now if it gets extreme or it changes, we're going to notice it again. Mechanoreceptors, physical distortion of their membranes. So tactile receptors sense touch, pressure, or vibration. Baroreceptors sense pressure changes in the walls of blood vessels and so on. Proprioceptors, as I said, respond to positions of joints and the muscle. Tactile receptors give very accurate, detailed information. Other receptors are not going to give as much information. So we're going to have root hair, plexus, the nerves that go to the base of our hairs. We'll talk about these different receptors as we get to them. So tactile receptors in the skin, free nerve endings, plexus at the root of the hair, Merkel receptors right at the base of our epidermis, Meissner's corpuscles right in the dermal papilla, this little indentations in the dermis. Deeper in the epidermis will be a laminated Pacinian corpuscle for deep pressure. And then we're going to have Ruffini corpuscles, which are involved in a touch also. Baroreceptors provide pressure on essential information. Arterial blood pressure is monitored, lung inflation, coordination of digestion, and how much fluid we have in our bladders. So there's baroreceptors in the digestive tract that are monitoring how much food is in there, where the food is, and so on. We have baroreceptors in the bladder that we all know when we get too much urine, we get a message. The lungs has baroreceptors that are monitoring what's happening in the lung so that normal breathing can be stimulated, and that we can also have, let's admit, okay, Celanese, okay, good. So in the lungs, the state of inflation, the position of the lungs, all that's monitored. Okay, in the baroreceptors around the heart, on the blood pressure, and also provide information on blood pressure to the cardiovascular and respiratory control centers in parts of the brain like the medulla oblongata. Proprioceptors monitor the angle, position of tension in the tendons, state of muscular contraction. They include muscle spindles and Golgi tendon apparatus. Chemical detection, incredibly important. So they monitor food in our gut. They monitor the level of carbon dioxide, oxygen, and hydrogen. Let me tell you guys a personal story. You guys know that I've had some surgery this year, and one of the last surgeries I had was, what treatment I had is I had blood clots in my lung. The blood clot ended up in my pulmonary artery, the artery that pumps blood from the right ventricle to the lungs. So I saw an x-ray and that was present. But my point of this story is before I saw the doctors, I had to walk 600 feet with an oximeter. So I was monitoring my oxygen saturation and my blood rate and blood pressure. So You're supposed to keep your oxygen saturation above 90%. As soon as I got toward the end of the walk and I was getting tired, as soon as my blood pressure, I'm sorry, as soon as my oxygen saturation went below 90, my heart immediately picked up its rate and number of contractions per minute. So that shows to me drastically, or in very, very clear contrast, and with information that is very, very accurate and quickly acted upon. So as soon as my oxygen saturation went below 90, my heart responded immediately. It said, we need more oxygen. We need more oxygen. So your heart does that all the time with the amount of CO2 in the blood, the oxygen, the pressure in the various vessels that are leaving the heart. And that's all monitors. It's incredible what we can do. Okay, chemoreceptors. They're sensitive to pH and CO2 in the cerebral spinal fluid. They are near the respiratory centers of the medulla oblongata. They trigger reflexes adjustment in the depth and rate of respiration. In the carotid arteries, there's chemoreceptors that monitor pH, CO2, and O2. Chemoreceptors in the aortic bodies, in the aorta of the heart. So pH, CO2, and O2 is constantly being monitored. Cranial nerve 9 and cranial nerve 10 will trigger adjustments to heart rate and respiratory rate. So all of that's being monitored constantly. We're never aware of that. It all happens automatically. And as long as you exercise and stay in good health, unlike me, it should last quite a while. But all those systems that monitor the pH of our blood, the oxygen content, the CO content of substances in the cerebral spinal fluid, all that is monitored constantly. We are an absolute wonder. And all of the animals in the world, all of the mammals, we'll look at them, all of our relatives, all work the same way. Okay. So let's stop there. And we'll record this one. And let's go back to here. Stop the recording. Stop recording for a moment.